So when you think of a clean room, what comes to mind? Probably, sealed walls, airtight doors, all that stuff. But what if I told you the real heart of the operation, the invisible engine that makes it all work, is something most people completely overlook? It's the HVAC system. And as we're about to see, getting that one thing wrong, well, it has massive consequences. See, it's this silent problem, but it's one that can bring a multi-million-dollar facility to its knees before it even opens its doors. To really get a feel for how critical this is, let's just dive into a real-world story.
Okay, picture this, a brand new state-of-the-art hospital operating theater complex in Western India. I mean, everything looked perfect. The construction was immaculate, the doors sealed tight, the flooring was totally seamless. It was, for all intents and purposes, ready to go.
But then came validation testing, and disaster. The particle counts were completely off the charts. It failed. So, they scrambled, they retested, and guess what? It failed again. Nobody could figure out why this supposedly pristine room was so incredibly contaminated. It turns out the problem wasn't the construction at all, it was the air itself. The contractor had installed a standard commercial HVAC system, the kind you'd find in any office building, not the highly specialized system that a clean room absolutely requires. This single mistake led to a catastrophic failure, a complete redesign, months of delays, and just staggering financial losses. And that story right there, it highlights the central mistake people make all the time. They think of cleanroom HVAC as just, a fancy form of air conditioning. But it is a completely different beast with a completely different mission. And this chart really nails the difference. Commercial HVAC, it's all about keeping you comfortable, right? Keeping you cool. But cleanroom HVAC, its entire focus is on contamination control. We're talking multi-stage HEPA filtration and incredibly precise pressure control, all to achieve microscopic purity. The two systems, they're just not in the same league. Okay, so if it's not just glorified AC, what exactly is it? Let's actually break down the system that creates that clean environment in the first place. At its very core, it's an engineering system built for one thing: total control. And I mean control over invisible particles, control over air pressure, and control over exactly how and where that air moves. The whole point is to create an environment that is stable, predictable, and ultra-pure, 24/7. And check this out. This chart really brings home the sheer power of these systems. We're looking at something called air changes per hour, or ACH. Now, a typical office, it swaps out its air about 4 times an hour. A hospital operating theater, we're up to 20 times. But an ISO 7 cleanroom, a staggering 60 times an hour. That's a full air replacement every single minute. That constant flushing is what keeps contaminants from ever building up. So how does it do that? Well, to get that level of control, the system relies on 3 critical pillars. And if you can understand these 3 components, you'll understand how basically any clean room works.
First up, we've got what's known as the air handling unit, or AHU. The easiest way to think about this is as the powerful lungs of the whole system. It's the central machine that's pulling in air, conditioning it, and then pushing it all the way through the clean room.
But, and this is a huge but, not all AHUs are created equal. A cleanroom AHU has multiple stages of filtration. It's built to be almost perfectly leak-proof, and it controls the air volume with incredible precision. It's just an entirely different class of engineering compared to your standard commercial unit. All right, let's move on to pillar number 2. This is where the real magic of purification happens, the HEPA filter. This is the microscopic gatekeeper that literally stops contaminants in their tracks. The numbers here are they're mind-boggling. A standard HEPA filter is rated to remove 99.97% of all particles as small as 0.3 microns. Just think about that for a second. That's a level of efficiency that is practically absolute. And to put that into perspective, a single human hair is about 70 microns wide. A HEPA filter is capturing particles that are more than 200 times smaller than that. We're talking about bacteria, tiny dust particles, stuff that is completely invisible to the naked eye. And that brings us to our third and final pillar, pressure control. Now, if HEPA filters are the gatekeepers, think of pressure as the invisible force field that keeps contamination from ever getting in. This is probably the single most important concept for preventing cross-contamination. And here's the beautifully simple principle behind it. The most sterile room is held at the highest pressure. The hallway right outside is at a slightly lower pressure, the support area is lower still, and the general area is neutral. Now, since air always flows from high pressure to low pressure, anytime a door opens, clean air flows out of the sterile room, not the other way around. This pressure cascade creates an invisible barrier, constantly pushing any potential contaminants away. It's brilliant.
So, now that we get how these pillars work together, let's turn this knowledge into actual power. If you are ever involved in a clean room project, here are 3 simple but vital questions you have to ask before you approve any HVAC design.
First things first, ask about the AHU. Is it dedicated to a single sterile zone, or is it shared between different areas? In critical environments like pharma or hospitals, a shared AHU is a huge red flag. Why? Because it creates a direct pathway for cross-contamination between rooms. You always want dedicated units for your most sensitive zones.
Second, and this one is so important, ask where the HEPA filters are physically located. The answer to this question tells you pretty much everything you need to know about the quality of the design.
See, a poor design will stick the HEPA filter way back inside the AHU. The problem with that is that the now clean air can just pick up new contaminants as it travels through all the ductwork. The gold standard is what we call terminal filtration. That's where the filter is the very last thing the air passes through, right there in the ceiling of the clean room itself. This guarantees the air entering that critical space is absolutely as pure as it can be.
And third, ask to see the pressure cascade diagram in the official drawings. It should look something like that step-by-step chart we saw earlier. If the engineers can't show you a clear, logical diagram of how pressure is controlled from room to room, then their entire contamination strategy is pretty much built on guesswork.
So, what's the big takeaway from all of this? It's that you have to think of a clean room as a single, unified system. The walls, the floors, the doors, they're all passive. They just contain the space. It's the HVAC system that is the active, dynamic force that actually creates the clean environment inside that space.
And that's really what it all comes down to. In any sterile facility, the HVAC isn't just another utility you bolt on at the end. It is the absolute foundation of your entire contamination control strategy. Getting it right is truly the difference between success and catastrophic failure.